Last week energy, this week really environmental policy. There's obviously some overlap, quite a bit in fact. But the first thing I want to say is today I am completely ignoring climate change for a couple of reasons. One is it has swallowed environmentalism and environmental policy alive, like the whale swallowing Jonah. And I think that's a mistake. And also, I could spend the whole hour and a half just on some of the difficulties of policy making, risk under uncertainty for climate change, and barely scratch the surface. And then the third part of it, why I think it's a mistake that climate change has come to swallow up everything else, is that there's a lot to be learned from other problems. Well, let me put it this way. If you wave a magic wand and make any kind of climate change whatsoever go away, you still have all the historic problems that have generated environmentalism going 50, 60 years ago. Species extinction, habitat, ecosystems, conventional air pollution, water pollution, toxic risk assessment from chemicals and whatever. All those problems still exist. And all those problems we try and devise policies for and implement and so forth. And there may be, another way of putting it is, if you ask me, is current climate policy succeeding or failing? My answer is yes. Mm-hmm. You can make the case for both of those at the same time. And that's a long story to go through, right? And we will in class next semester. But I think there's a lot to be learned about how to think about climate policy, which is completely different from other environmental problems because of its long time horizon. But it may be useful to learn the nuts and bolts of other environmental problems, and I'll bet that will make for better decisions about climate over time, which we're going to be doing for a very long time. So that's first point. You won't hear anything about climate much today. Second, I like to say about the environment, it comes in two parts. The two parts I call are romance and sludge. And there's some overlap. But what I mean is romance is the obvious things. It's bugs and bunnies and polar bears and mountains and streams and nature, rivers and so forth. Sludge is exactly what you think. It's polychlorinated biphenyls and nitrous oxide emissions and things of that kind, sewage. We have policies devoted to wilderness preservation and land conservation and so forth, and of course sludge we regulate heavily. With that said, I'll give you my first chart, which is that is the growth over the years of all of our environmental statutes in the U.S., and this isn't even all of them. These are just the major ones that were enacted by Congress over time. And then, of course, you have more things laid out by different agencies. And this breaks off about 2010, and not a lot has passed Congress in the last 15 years, and that in itself is an important story. I think that when it comes to the environment, there are three key analytical tasks with the two subpoints there in points 1 and 2. First thing is, whatever problem you're thinking of, is to do some kind of risk assessment. What's the problem here? How serious is it? And then an absolute and comparative. By that I mean, if you look at a problem in isolation, you might say, well, that's a problem. I'll give you some examples along the way. But then compare to what other problems? And here, the problem of considering trade-offs comes into view. And I'll give you a couple of examples of where solutions or policies directed at one environmental problem have had the perverse effect of making other environmental problems worse. And so balancing those trade-offs is something we're very bad at. But I think a good environmental analysis needs to include that up front. Second thing is, whatever problem you may discover, and it's amazing how we come along and we'll discover that we had a problem we didn't think we had, or we can measure things better. And the first question to ask is this something that's getting better or getting worse? And so there, we need data to find out. And I'll give you a couple of the major data sources to know about today, along with noting some problems we have very poor data about. It's impossible to make significant conclusions about whether things are getting better or worse. Some problems are easy to measure, like conventional air pollution is an easy thing to measure. Other big problems are hard to measure, like water pollution. I think one great detail about why that's hard to measure. And then finally, what are our principles of action? And I put in parentheses values. That's the way we usually talk about it. I'll just say I hate the word values. This is what comes from Nietzsche, really. And it's too often then the premise is it's subjective when it shouldn't be. So what are our guiding principles? And I'll say more about that at the end, what that means and why there's the things you want to keep in mind as you think about either capstone projects or whatever aspect of this issue may interest you. Now, the thing about the environment is, there's some old headlines. It has been the subject of gloom and doom forever, going back to really actually since at least the middle of the 20th century. One of the early bestsellers about things are going badly wrong with the whole planet was Our Plundered Planet by Fairfield Osborne in 1947. I'm going to skip over the State of the World reports, which aren't done anymore. Americans think environmental quality is getting worse. They don't take these polls anymore. But I'll just dwell on a couple of major totems and historical milestones along the way. And one of them was the famous 1968 book, The Population Bomb by Paul Ehrlich, who's still alive. He's very old now. I've met him a few times. This book was a monster bestseller, sold millions of copies, translated into dozens of foreign languages. And you can see his prediction was, we're going to have mass starvation and hundreds of millions will die in the 1970s, just a few years later. Somehow I missed that happening. It didn't happen. This is one of the most widely discredited books of all time, but he got famous for it. One of those MacArthur Genius Prizes and a UN prize, and he's a very charismatic guy. This is some old information, but in fact, and this is out of date. I really need to update this. It's 30 years ago. Is that even though world population nearly doubled from the 60s to the 90s, world cropland only expanded by 8%, which doesn't sound like very much, and yet the number of calories went up by about 20% for the world as a whole. It's actually more since then. It's true now that whenever there's a food shortage, it's not a resource constraint. It's usually a political problem, a civil war, an evil government. There's an old screenshot. It's big grainy. That's me on the right, debating Paul Ehrlich on a PBS TV show exactly 20 years ago. When I was a younger guy and had a little more hair. Okay.
Is that Peter Robinson?
That's Peter's Uncommon Knowledge show back when it was on broadcast on PBS. Right. And I also debated Ehrlich once at the New School in New York in 2006. We actually got along pretty well because I go at it in a different way than most people do, and he kind of liked that because anyway, I could go on about that for a while, but time is short. The great book about where this went wrong is by Matthew Connolly, who's a historian at Columbia University. A conventional liberal, I think, but this book is absolutely savage in its critique of the whole sort of anti-population movement and some of the horrors it led to. Forced sterilizations in India on a wide scale. There was nothing voluntary about it, right? It was very coercive. And then of course he goes through the data and shows why the premise turned out to be completely wrong. And by the way, it's now, you can find headlines in the New York Times in the last couple of years. The big worry now, believe it or not, is the falling fertility rates around the world, and that global population is going to peak probably, within your lifetimes for sure, but maybe as soon as 20, 30 years from now, and then population is going to start falling. And if you wrote the population bomb, maybe the population implosion, hard to know what the future will bring. There's always surprises along the way. But it's not unthinkable that 150 years from now, the biggest problem facing the world will be population falling too fast and too much for a bunch of economic reasons. Population is just one. What we said about that in a minute, and I'll tell you why. But there's always great predictions going back to the, no, not that. Let me see. Come back. Where are you? There we go. As early as 1890, everybody said we're going to run out of oil. By 1935, President Carter, we're going to use all the oil by the end of the next decade, meaning by 1990 or 2000 or so. Yeah, 1990. And in fact, in 1980, this big report came out. This thing's the size of a phone book, and I just picked out the oil prediction here. This thing had made huge news when this thing came out because a big team of scientists that was all running. We're going to cut down all our forests, we're going to run out of our minerals, water. There's going to be no oil, and it had all these energy shocks in the 70s. So there's the prediction: $100 a barrel by the year 2000, and the world will be 20 million barrels a day short. Anyone want to guess what the world looked like in the year 2000? Looked like this. This is from 1999 from The Economist. The price of oil collapsed down to about $10 a barrel. So that Global 2000 report was wrong by an order of magnitude. Not just a little. It was just so far off that you wonder why. Nobody ever mentions that report anymore except for me. It's an easy thing to do a big inventory of predictions that have gone on. And by the way, this has been a huge problem for environmentalists, is they've been crying wolf for so long that the public, and I got survey data for this, the public suffers from what I call apocalypse fatigue. And this is a huge problem for the people concerned about climate change, because a lot of people say, I've heard this before. Call me when you've got something that's going to bug me next week. And when you have a long time horizon, that's also a significant problem. And like I say, these lists can go on forever. The other thing is, one reason why the population bomb was so popular is it wasn't really a new idea. I'd say that, your grandfather's environmentalism, I think I can't put it that way for this crowd, was very much inspired by the famous economist Thomas Malthus, who lived in the early 19th century. And he's the one who said, oh boy, this prosperity is bad. People are going to have more babies. Population's going to grow. We're going to outstrip resources. And then you'll have ecological and demographic collapse because people will starve to death. And so Malthusianism's still with us, but the point was that understood human beings as liabilities. We're only consumers. The idea for a long time to say, yeah, but human beings come with two hands and a brain. And Malthus's predictions turned out to be wrong, well, for a bunch of reasons. But one is we are a creative species. But that view really stuck for a long time, and so it gave rise to the limits to growth mentality. Well, we're heading towards collapse, and so we've got to limit population growth. We've got to limit economic growth. And one of my favorite expressions of this is from 1993, full-page ad in the New York Times by David Brower. He was a famous figure in environmentalism in the 60s and 70s. He died around 1997. And this was a full-page ad in the New York Times telling incoming President Clinton, please, please, please stop using cost-benefit analysis for regulation. And Clinton ignored him. So did Obama, by the way. Obama and his top environmental guru, Cass Sunstein, said, no, cost-benefit analysis is good for environmental regulation. Why? There's a certain ignorance to this. Most environmentalists won't say that now, but this was a very popular view 30, 40 years ago. The point is, what is money? Well, it's a lot of things, but it's a proxy for resources. If you're wasting money or spending on expensive things so you don't have it for something else, it's probably environmentally counterproductive, because it means you're wasting resources or not using them efficiently. So that's kind of faded, hopefully enough. Or another way to think about this problem is I remember the first Earth Day in 1970. It was in the 6th grade out in the San Gabriel Valley, where the air quality was horrible. I'll come to that in due course. And one of the things that got huge publicity is things are so bad, the river in Cleveland caught fire, the Cuyahoga River. And here's a picture of the Cuyahoga River on fire. Now, the interesting thing about that fire in the spring of 1969 is no one quite knows how it started. There's some theories I'll skip over. And the interesting thing about that was the fire didn't burn very long. The fire department got there pretty fast. They put out the fire, and there wasn't time for the Cleveland Plain Dealer or any other media to get there and take a picture. Now, if you're with me here, I'm going fast. I just said the river caught fire, but there wasn't time to get a picture. That's because that picture is the Cuyahoga River fire of 1956, which burned longer, and I had time to get a picture of it. So all the pictures used in 1969 were of a 15-year-old picture. Turns out if you go through the history, the Cuyahoga River was catching fire as early as the 1880s, because it was an open sewer. That's when you had the steel plants and the early refineries of Standard Oil there on the banks of it, and it was pretty ugly. But by 1960, and by the way, people would say, well, I guess there's not much we can do about it. Yeah, it's nasty, but it's the price of progress. The point is, by 1969, social sentiment was such that that's intolerable. You can't put up with that anymore. Long, interesting history to early regulation of water quality in Ohio before the federal government got in on it. But today, the Cuyahoga River, you can swim in it. You can. Oh, there are no fish. I mean, nothing could live in it back in those days. Today, you can fish in the Cuyahoga River, even in downtown Cleveland. You might even be able to get away with drinking the water, although I don't recommend it necessarily because of runoff, not from industrial pollution. But here's the point, and I'll expand on it from here. My one-sentence summary is the affluent society does not want to be the effluent society. That's my slogan, right? In other words, there is, and you can actually trace out a correlation around the world, that it turns out that the first step of environmental improvement is economic growth. And the key concept is something that's come to be known as the environmental Kuznets curve. And here's the abstract expression of it. So Simon Kuznets was an economist in the 50s, and he became famous and won one of the early Nobel Prizes in economics for saying, look, here's how income inequality goes. As an economy grows and a country prospers, income inequality gets worse. But then at a certain point, the middle class starts to grow as prosperity is distributed more widely and income inequality goes down. Somebody came along and said, you know, I'll bet that same phenomenon works for the environment. That as countries start to grow and use their resources and they want to get richer and live better material lives, they're going to degrade their environment. But at a certain point, like when a river catches fire in 1969, after 2 decades of great economic growth, people say, yuck, we're not going to tolerate that anymore. So that's the stylized version. That as you get richer in per capita income, your environmental quality or environmental degradation gets better. Is there evidence for this in the real world? There's lots of it. Here's one I like, is from London. There's a second line here. Do I have to prep? Yeah, I do. Some old animations. This is, if you can see the bottom axis, it's 16th century up to the 1980s. Top line is sulfur dioxide. That represents emissions from coal use, which you can see starts back in the 1600s. And then the bottom one, the blue line, smoke, that'd be from wood fires, in urbanizing England. And a couple things to notice about this. One is that when does it start falling, especially the SO2 line? It starts falling about 1900. Long before there's environmental movement, before there's much direct environmental regulation. Partly that's efficiency gains. But the other thing to be said, that rise in coal, starting in the 17th century, that kept England from cutting down every single tree they had. Because they were, before they started to burn coal, they were cutting down their forests like crazy. So coal, for all the reasons we don't like it today, represented an environmental improvement. There's a trade-off there. You got a new form of pollution, which was sulfur dioxide, and smoke is just incompletely burned wood from low-tech fireplaces. And you don't quite catch on this line, is somewhere in that long downslope, you did start getting regulation directly by first the city of London and the English government. There's some great books about all this. I put together these headlines myself. In 1952, that picture on the left was taken in the daytime in London in 1952. They had an inversion over England, like inversion layers you get, and it trapped the coal smoke and sulfur dioxide. And so you had these headlines. They said fog. This is where smog came from, by the way, the term we're used to. It wasn't until weeks later they figured out, because the hospitals were calling in the number of people who come in with respiratory difficulties and then fatalities. About 5,000 people died that week in London and Manchester. And that's when they said, we really got to cut back on coal use. You've either got to have boilers that are, boilers that use coal. But a lot of people in London, you burn coal in your house. Coal was an upgrade from your fireplace. So you'd get electric deliveries of coal to your house, you'd shovel it into your own furnace. It's crazy. Think about it today. So, but the point is you go back to this, that looks like the environmental Kuznets curve. It's economic growth that explains really why you began to see improvements there. People got better furnaces. They switched to fuel oil, which was a whole lot better than coal, and so forth. There's a lot to that story. And there's an American version of it, which looks like this. This is a chart the EPA puts out every year, and it almost never gets noticed in the media or anywhere else. And so this goes back to 1970, the first Earth Day. That's kind of your baseline for modern environmentalism. And you can see that our economy has gone up 300% since then in real terms. We've more than tripled the amount of miles we drive in our cars. And yet, all the way down the bottom, aggregate emissions, this is economy-wide of the main 6 air pollutants we regulate. So I'll mostly skip over details on that except for one example today. It's gone down since then. This is what's known as decoupling. It's a big term in environmentalism today, which is, in other words, what was thought to be 50 years ago an inexorable link between economic growth and environmental degradation turns out not to happen that way. And you can see there the first line up from the bottom is absolute CO2 emissions going down. Not relatively, but absolutely, especially taking off the last few years. Population growth and all the rest. That's the environmental consequence curve in action in the US. There's several good books about all this. Did any of you go to the, well actually some of your first year students, last spring we had the conference on nuclear power here at the Wilburn Auditorium, and Ted Nordhaus, author on the left, was part of the panel that day. And Ted and then his co-author Michael Schellenberger, who's off doing other stuff these days, but they consider themselves, liberal progressives. Very enthusiastic about Obama, and then later Joe Biden. They love the Inflation Reduction Act, which is really a climate bill. You can say that they thought it was a huge mistake for environmentalists to think economic growth was the problem. And their conclusion is few things have hampered environmentalism more than that view. They weren't the first to say this. There's a great book from about 2006 from Jack Hollander, who was then retiring as a physicist at UC Berkeley. I asked him, how'd you get interested in the environment? He says, well, I was working on the Bobby Kennedy for President campaign in 1968. And so you see the central argument of the book is that actually poverty is the problem, and that if you want an improving environment on the global scale, you want prosperity. And so, all right, there's a contention. How about some evidence? And I'll give you some right here. So the UN does a thing every, I think, 5 years, maybe it's 10 years, the Global Forest Resource Assessment. I'm a total geek for these kind of data reports. And deforestation's been on our mind for quite a while. And what you see here is, you see the bottom, Asia, Oceania, Europe, North and Central America, and then South America and Africa. And actually, North and Central America, if you disaggregate it, you see substantial growth in forest land in the US and Canada, less so in Mexico and Central America. And so it comes out about even if you add us together with Central America. And then what do you see here? South America and Africa are going backwards. And in fact, South America has cut their deforestation rate in half, but it's still quite a lot. Africa's getting worse. What do those two continents have in common? They're both poor, so what are you going to say? So,
well, they use wood to heat their homes, and they use wood to cook their food, and they have to draw wood, and they don't have power.
Okay. That's when they're not using cow dung, and things are really horrible for health. Yes?
Yeah, so there's a country, I can't remember, but there was a country where most of our air comes through their Amazon, but like most of our, I'm trying to remember the country, but there was a fire in that.
Yes, yeah, it might have been the Amazon fire, right?
Yeah. Oh, okay, that's the one.
I think it's that one. It's also true. I mean, I'll come to the Clean Air Act a little bit in a little while. We can now detect pollution blowing all the way over from China on a regular basis in some of our air quality monitors here in California. It's not yet enough to make our, I'll just skip over that. But it's still, I mean, yes, it's a global thing. Yeah. But a fire, of course, should be a temporary thing. But yeah, so you said people use wood. They're poor. Why are they using wood and cow dung? Because they're poor. There's a second point, though.
But you can also say they're poor because they don't have any energy.
Well, they don't have important thought. There's a next, Avery?
There's a lot of political instability.
Very political instability, corruption. you can do, I used to do this. You can take the world, who is it? There's the UN has some, I forget which operation it is, an evaluation of corruption, political corruption. And you can usually calculate political corruption with environmental quality on a plot. It's the variance is pretty big, but you can correlate it. But second, so there's corruption, poor institutions, no property rights, or very little property rights protection, which is the next important point to come to. Two questions. One is, how come nobody ever washes a rented car? You ever asked that question?
Because they wash it for you.
Well, okay, but you don't own it. They'll do it for you. Someone else will do it. They do it for you, right? But you don't own it, right? Let me give a second question, which helps us move along a little bit to the point to be absorbed. So suppose, as a thought experiment, we didn't have cattle ranches. We just let the cattle run free across the country, and if McDonald's wanted to get ground beef or hamburgers, what would they do? They just send out some cowboys and round up some cows. and take them to where you turn cows into hamburger patties. How would that work? What happened to the cow population? Wouldn't it be chaotic and overhunted? Because by the way, the problem is, if you're just cows running freely out on the plain somewhere, and there's a cow, and you don't grab that cow, the next person might. So what's your incentive? It's to grab that cow. Works that way with forests in Africa. In fact, if you break down the data in Africa, you see some statistically significant differences between places that allow the population, the citizens, to have ownership of forests and property rights to them, and places that don't. Guess what? The people that get to own their forests, there's much less deforestation. In fact, there's usually forest growth. So I mentioned cows. How do we do fishing in the world? So we're always worried about, collapsing fisheries, overfishing. There are various schemes to regulate it by limiting the fishing season, quotas, and so forth. And it's a mixed record. Some of these things work after a fashion. There's a very good study in Science Magazine a few years ago. And so again, the fishing was just like my analogy of cows running freely across the plain instead of being behind barbed wire. The question is, what would the oceanic equivalent of a barbed wire fence and fish ranching look like? And I don't mean fish farming like we do for salmon. I mean, fisheries where you want to catch cod and the Chilean sea bass, which is actually the Patagonian toothfish, but no one wants to eat something like that on the menu. That's why we gave it that name. Okay. Long story, but this chart gives their conclusion, which is ITQs are international tradable quotas. In other words, you'd have to bid, and it kind of creates a cartel. It's not a perfect market solution, but the point is it removes the incentive to grab every fish possible, because if you don't, the next person is going to take it, which is the perverse incentive of the way we've done fisheries really until recent decades. And so there's the dark line is fisheries that have been in decline, or the percent that are rated as collapsed by various international bodies that try and track this. And if we'd actually use the property rights-based approach, you would have much less of it. And it's catching on around the world. So Iceland, Norway, parts of the US, Pacific Northwest for salmon and things, are starting to go with this idea. The point is, let people own the rights to fish a certain area. Limit entrance. You can't just have free entry to it, and make it tradable. So if I can buy it from you, you can buy it from me. So there's a market for it. And that would work a whole lot better. So markets are your friend. Okay, so economic growth, property rights. I'll come back to all of those. Another example, I'm going to draw into air pollution here indirectly. Another example of the Kuznets curve in action and trade-offs and the role of progress, I think can come from, this is the Lower East Side of New York. This picture is by the famous Jacob Riis, who was one of the early sort of sociologists of slums and bad housing and so forth, and a very influential figure back in the reform era of the early progressive movement. What I always like to say is, what do you see here? A whole lot of horse-drawn carriages. Or, there's another scene of it here. Horses and carriages were, and that was intra-city, I should say. That was the dominant mode of transportation in hauling goods around in New York and other major cities. And I think the estimates are, I didn't go back and check, but I think it generated, I think the figure was 50,000 pounds of manure a day. And the gallons of urine from horses was also huge. Now imagine being a woman with a long dress. By the way, this is not really fanciful. I have an article somewhere in my files of Scientific American saying, fortunately, the short skirt is coming into fashion. Because just imagine getting home, walking through the street in New York in those days. And what a huge, they try to shovel it up, but it's difficult, right? And it's a losing battle. But beyond all that, so the point is, let's see where this is going to. Well, I'm going to say that for a moment. I've got these mixed up a little bit. Yeah, I'm going to skip over that. No, I won't. I've got these out of order. Sorry. Let me go ahead here. Two more. I think I mentioned this last week or the week before, but here's the data. We used to use over 90 million acres of land, farmland, mostly in the Northeast, to grow hay and oats for our horses in the cities. So, if I'm Henry Ford in 1915, I think my bumper sticker would have said, "Save farmland, drive car." Because the car solves the problem of horse dung on the streets and urine on the streets and saves a whole lot of farmland. And this is directly related to the reforestation of the Northeast in America that's been going on ever since. So yeah, cars turned out to be big air polluters. They ended up being a solution to another set of environmental problems. And I want to go back to showing you that we used to use a lot of wood. It's actually like 80% of our energy was total energy consumption in 1900 was from wood, and not just people having fireplaces, but also, your Chinese laundries in San Francisco, their wood-fired boilers for laundry was a big issue in the, and it starts going down when we start getting what? Kerosene, fuel oil, a little bit of natural gas. And you see it pops up again there. Why did that happen? Well, it's a little before that. I tilted the axis on this. It's the Great Depression. What happens during the Great Depression? Well, your income goes down. You quit buying fuel oil and kerosene. Wood's cheap, maybe even free, depending on where you live. You just go chop down a tree or scrounge it up, and you get your fireplace going again. I always like to show this comparison, because this also illustrates the effect of, the wealth effect or the environmental Kuznets curve again. The top one is the same data I had on that previous chart, which is wood used for energy. And then the bottom one is households with telephones. So you see what happens there. When suddenly your income falls because the economy's terrible, you go back to wood because it's cheaper. So wood use goes way back up. And then, the telephone, what a great luxury. You can see at the beginning of the Great Depression, only about 40-some% of households had telephones. And then, if you've lost your job, your income's going down, you're worried about the future, you ditch your telephone because it's a luxury you can't. So it goes down, right? And then what happens is, we get prosperity back and people get their telephones. And, the government stopped keeping data on wood use for energy in around 1970, 71. But it's, at that point, it's a trivial amount. It's, old codgers in Vermont with their wood stoves and stuff like that. Okay, now let's talk about those cars. So the one on the upper left, that's I think like a 68 or 69 Mustang parked in a driveway. And the bottom one, now Mustangs now are all electric, is what Ford has done, but that's like I think about a 2015 Mustang. You see the background's blurry, so it's going down the highway at, let's say, 60 miles an hour. Question, which one of these cars is giving off more air pollution? Anyone want to guess? It is completely mind-blowing. You know where I'm at. Of course, it's a trick question.
Yes.
So what's the answer?
The bottom one.
No. Yeah.
Tesla?
Sorry?
Tesla? You know,
No. That's a gasoline-powered car. Sorry.
Yeah.
But it's a gasoline, an internal combustion engine car. I should be more clear and explicit, but I'm trying at the same time. That's a gasoline-powered car going down the road 60 miles an hour. It's got a tailpipe. That one's parked with the engine turned off in the driveway. Which one's giving off more pollution? I know you're looking incredulous because you know the answer I'm about to give you. It's the car parked in the driveway. You say, how can that be? It's not running, it's not burning gas. True, but it's leaking gasoline fumes like crazy because that car had a carburetor and it had a gas tank. It didn't have the seal cap like we're all used to seeing now. And I'm old enough to have grown up with what do teenage boys do with their first old used Chevy? You fiddle endlessly with a carburetor. That car didn't have a carburetor. We moved to fuel-injected engines. That's step one. That makes the fuel consumption more efficient. We sealed up everything so it doesn't just evaporate out of the car. And so it sounds mind-blowing to say that, but it actually is true. And then there's more emissions control technology. And so the answer here is point 3 on aspects of environment is technological change and improvement. You can't just wave a magic wand to make that happen. But some of the aspects of this are really astounding, and so I will show you one example of it. So 68, that Mustang, hydrocarbon emissions, that's or volatile organic compounds we call it. It was grams per mile driven. You can see it's over, it's almost 11 grams per mile emitted of volatile organic compounds. That's several things. It's the stuff just evaporating out of the car that's old, primitive technology. And incomplete burned hydrocarbons. It used to be those old carburetor engines were not very efficient in burning all the fuel. So a lot of sort of unburned gasoline fuels would go out the tailpipe. And that's what made our smog problem so bad, especially in LA, but any place you have a lot of cars. So, the industry got after it. And I always like to say that the real heroes of air quality improvement in America, not really environmental lawyers who filed lawsuits. I mean, they played a role, but it's nerdy engineers with pocket protectors who figured out how to revolutionize the way car engines worked and develop emissions control technology so that now, I broke this off in 2004. Nowadays, brand new cars are super low polluting. Gasoline cars are super low polluting. And some of the results look like this. We used to have 16 million tons a year of automobile hydrocarbon emissions, that's VOCs are, and now it's down to under 2,000, under 1,000. It's pretty small. And that's mostly will be old cars that have been improperly maintained or out of tune, or have broken emissions equipment. A properly running brand new gasoline car emits almost no conventional air pollution. Conventional air, that's an important point on the climate story. For industry as a whole, because cars weren't the only source of hydrocarbons, it's oil refineries, chemical plants, steel, any heavy industry. You can see that has declined substantially over the years. Nitrogen oxide is another part of the story. It's gone way down. I'm just going to skip over that. Carbon monoxide. Did you have a question?
Yeah, our former president, he made an interesting comment. He said, "Beautiful, clean coal." And I'm interested if maybe part of that, I mean, he's prone to exaggerations and whatnot, but is this kind of telling that story? Have our coal plants and similar other technologies actually lowered their emissions?
Oh, yeah. I have skipped over the sulfur dioxide and coal story. But actually, it fits here too. So, we have, I'm a little rusty on this, but I think the bottom line number is right. Even before we started shutting down coal plants, which is something accelerated the last 10 years, sulfur dioxide emissions, that's what we cared about most from 1970 on, fell by more than 75%. Even as the output of coal-fired power almost tripled. By the way, one of the things people forget about Jimmy Carter, great Jimmy Carter, he said America is the Saudi Arabia of coal. And he set in motion a huge expansion of coal-fired power in the late 70s and early 80s, which then, by around the year 2000, we said, oh, wait a minute, we don't like that. Why? Because carbon dioxide. So the whole climate issue came along. Because one thing that's true, so this is what's left out of, reducing conventional air pollution so that smog in LA was no longer as nasty as it was. That involved making the engines run more efficiently and so forth. It did not reduce their carbon dioxide output. The same is true of coal plants. You still got carbon dioxide emissions. Now, carbon dioxide by itself is, it's harmless, right? It's plant food. We never worried about it as a noxious air pollutant that would affect human health, except at ridiculously high concentrations, like you're stuck in a closet. But never mind that. Not ambient air. By the way, one of our emissions control technologies, the old catalytic converter that people like to steal now for the platinum, that actually increased carbon dioxide emissions. Here's why. Carbon monoxide, right? That is a poisonous gas. You get a high concentration of that and you will die. And we didn't know, by the way, until the 60s that so many urban areas have high levels of carbon monoxide. We hadn't really measured them. Once we did, we said, holy cow, it's not just Los Angeles, it's Milwaukee and Chicago and Atlanta and going down the list. So one of the things a catalytic converter does is it converts carbon monoxide into, guess what, carbon dioxide and water. Have you ever noticed you start up a car on a cold morning, a gasoline car, and you'll see a little water vapor come out the back? That's condensation of the catalyzed emissions. And the water doesn't disappear until all the engine and the tailpipe warm up. Then you just get invisible smoke. But it was on purpose when we designed catalytic converters to convert carbon monoxide into carbon dioxide. Now, it's not a significant amount in the grand scheme of carbon dioxide inventories for climate change, but it's still the wrong direction if you're trying to focus on carbon dioxide. Does that help answer your question a little bit? So it's two different things. We could reduce carbon monoxide, volatile organic compounds, we could reduce all that from cars and from power plants without reducing their output. But you can't do that. You can't reduce carbon dioxide from those fuels except by using less of those fuels. So in other words, all those revolutions in technology meant we could use more of those fuels for the purpose of conventional air pollution, but not for carbon dioxide. That's one of the wicked, perverse problems of carbon dioxide as a greenhouse gas for climate policy. So it's a different kind of thing, and lots of footnotes to follow. Just real quickly, this is a book I did. The worst areas have had the greatest improvement in air quality around the country. We'll skip over all that. Los Angeles. So I won't explain the 1 hour and 8 hour ozone standards now and how they changed all the rest of it. But here's the story. When I'm a kid in the mid-70s, almost 200 days a year above the ozone standard. And the further out you get in the tough areas like Pasadena, where I grew up, or Riverside, San Bernardino, Santa Cruz Valley was always worse. And now it's down to, actually this book's out, I need to update this. It's almost 20 years old now. There are large parts of the LA area that are part of the whole basin, including here in Malibu, that have not seen a single exceedance for probably 20 years. I'll bet Malibu has not had an exceedance of the 1 hour standard for 20 years. I'd have to look up the monitor, because we have about 60 different monitors scattered around the basin. The stubborn areas I already mentioned, Riverside, San Bernardino, they still have the exceedances. Santa Cruz Valley. Millions of people in the LA basin are not exposed to serious air quality problems anymore. Unlike when I was a kid, I can tell you horror stories. I'm always amazed when I come back to LA, I can see the mountains. You can go weeks at a time. And in Pasadena, you're a mile from the mountains. You can go days at a time and not see them. That's how bad it was. It really was extreme. And not anymore. I've got some great color-coded maps I got to find. They're way out of date because they were very difficult to make. This is I usually don't like charts like this, and I'm not going to dwell on it, but you see everything goes down from all the main the 6 major categories. I'm skipping over all those for now. But you can read all about them in an old book of mine. I co-authored with Joel Schwartz. I think this book was 2007, so it's way out of date, but it was an evaluation of the Clean Air Act and the way it matched up with health risks and all kinds of things. Could be something to update as a project. I'll come back to that, baby. So, I don't know, by starting around 2005, maybe even earlier than that, you started seeing more and more, what I might call sort of conventional academics or even conventional environmentalists starting to say, hey, wait a minute, things are getting better in the US. This guy was a professor of public health, Seymour Gard at the University of Pittsburgh, and he wrote about how things are improving. And he had lots of measures, and one of the things was, he said, I found out at all these public health conferences I was going to that nobody knew this. I was surprised that nobody knew this. He said, I didn't really know it until I looked at the data. That's one. That book's now, getting close to, I think it came out in 2008 or 2009. This is a brand new book by Hannah Ritchie, and she's like the #2 person at the Our World and Data website I mentioned last week that Max Roser runs out of Oxford. And she's an optimist. She says, yeah, I got big problems, but here's why you should be optimistic about it. And I'll see, I think she lives in Oxford. I might try and get her on Zoom. I've met her several times. I might want to try and get her on Zoom. Problem is the time change, it could be late at night. I don't know how late she stays up. We'll see. But it's one possibility. I recommend this book. It's just out. You see it's got an endorsement from Bill Gates here at the top on the front cover. And one of my complaints is environmentalists hate good news. They hate, environmental advocates. This has changed a little bit because this is back in 2000s. I went to see USA Today and said, this is happening? He said, no, we didn't know that was happening. They did an editorial about it. And they had Fred Krupp, who still runs environmental defense. He says, oh, yeah, we made progress, but things are still terrible. It's, I think certain kinds of environmentalists, this is not true of most academics, I think, most specialists, but a lot of the environmental activists, they're not happy unless they're sad. I actually think that's a sort of psychology going on. I'm going to skip over this report from 2004. Well, maybe I won't. This was a really interesting and ambitious project. The Heinz Center assembled about 125 of the top experts in various subfields, and what they wanted to do was, what do we know about our ecosystems, and what's the data out there? And to make a long story short, you got to define an ecosystem. That's not a simple thing. They worked through that. And then what they found was they identified about 130 things to measure. They said we only have data to make judgments for about 40 of them. For everything else, there's not enough data, and we just don't know. And here are the things we need to know. And I got to know the project director for this, a guy named Robin O'Malley, who then went back to the Senate to work for one of the senators. Anyway, it was such a labor-intensive project that they couldn't keep it going. I mean, they had a lot of very eminent people as part of the team. And, you know, they're all busy people, other things to do. And so they'd hoped that they was going to be able to make this like an annual report every 5 years. And they just, even with the resources of the Heinz Center, which, you know, Heinz ketchup and all that, they said we couldn't keep it going. But it's a great example. I think it's still worth reading this report. It's a great example of the problems of assessment. So, you know, some things we have great data for, like air pollution, other things not so much. And this report was very useful for understanding all that. Now let's go to some data sources. You know, last week I went through a bunch on energy. And actually, I'm going to get out of here if I can and actually go to that website. So no, I don't want that. I want, no, I don't want that either. I want you. Why is that there? Okay. So for the longest time, the EPA website, like so many government websites, it's huge, it's sprawling, it's unmanageable because they have too many people to work on it. And they finally, around 2007 or 8, started a report on the environment with sort of consolidated data sets integrated with other agencies. I was a peer reviewer for designing and developing this. And I mean, I'll have this link for you in a Word file that Melissa will distribute. But they developed a report on the environment, a whole lot of indicators, and just give you an example. What did I just do? I just screwed that up. Here we go. Let's just pull up the Explore the indicators. So you have them for, well, here they're started in alphabetical order. And some of these they haven't kept up very well. Let's look at, so the third one down there, carbon storage in forests. That's a good thing to study. I've been curious about trying to quantify that for a long time. You see it goes 1990 to 2016, and last updated in 2018. So here's an example of a data set that looks promising, but no one's keeping it up and extending it. But you can click on one of these, and what you'll get is a sort of summary chart, along with a little link right there to download the image. No, I'm on the next one. Download the data. You can download the data from any of these indicators from Excel spreadsheet. Oh my God, when I first started doing trend analysis in the early 90s, I had to go to the EPA library, find a printed report, find the appendix, see 50 numbers, and enter them manually on an Excel spreadsheet, which took forever, of course, right? I had an intern and stuff to help. But now, they do it all for you. This is the single best resource, I think, when you want to find the data. What do we know? What do we have? What trends can we make out from what data we do have? And so this is an important one to bookmark. Let's go back now to where we were. I wonder if I can resume where I left off. Yeah, play from current slide. Okay. So that's a great site, and I just give you the merest hint of it because, oh my gosh, it's 5 minutes to 1. Here's wetlands. I'm going to skip over that. That things are getting better. Some things are not getting better, and one of them is, you may have heard of the dead zone in the Gulf of Mexico that happens every summer or fall. Or it's hypoxia, which means shortage of oxygen, the fish die, algae blooms, and all bad stuff happens. It does tend to be temporary, but it's serious. And so here's off New Orleans there, and you can see that the trend here in the bottom is just bumps along. There's no trend up or down. And what's the main cause of this? Anyone know? I mean, you can kind of guess a little bit. It's obviously runoff from the Mississippi River. What goes into the river? A lot of nitrogen. What causes all that much nitrogen? Fertilizer on our crops in the in the heartland, because the Mississippi Basin is ginormous. Why are we using so much nitrogen? A lot of it is to grow corn. What are we doing with all that corn? Well, it makes us fat, but also we use it for ethanol. So this is a great idea in 1990. Let's have ethanol, make us energy independent. It'll lower air pollution. It doesn't. Most environmentalists. Al Gore turned against ethanol 20 years ago. But now the farmers love it because they get subsidies for it. The refiners are hooked on it because they get subsidies for it. Anyway, the National Research Council, is that who it was? They did a report more than 10 years ago saying, we have policy goals to reduce hypoxia in the Gulf. But the conclusion of the study was, we're not going to be able to reduce nitrogen loads enough as long as we have the scale of ethanol mandates and farmers using nitrogen fertilizer. So there's two environmental policies goals headed in collision with one another. It's a great example of a trade-off where one idea, which turns out to be a bad idea, but hard to get rid of bad ideas, is harmful for another one. There are other areas that have hypoxia problems. Long Island Sound, but it's been getting better. They don't have the nitrogen loading problem that you have in the Mississippi Basin. So here's your total nitrogen loads, and they go up and down a bit. It also does depend on the rainfall amount during the year. So that's partly a natural cycle. Okay. I'll move to a conclusion here, and then we can do questions. I've gone really fast over just a few things, really. So I said that, the old school 1970s Paul Ehrlich era environmentalism was very Malthusian, limits to growth. Humans are, consumers and bad for the planet. In recent years, there's what's been known as an eco-modernist movement. I've got the website, which I'll include on that, and you can read their manifesto. Ted Nordhaus, previously mentioned, was one of the many authors of this. It's an international group of people who wrote it. And it's explicitly anti-Malthusian. They reject that framework at the beginning, embrace economic growth, technology, and boy, they've got the receipts on all of this. They're optimists about the future. So yeah, big problems, but this is something that but it's controversial. You might say the old faith won't go away. Its opposition, which has risen in direct response to eco-modernism, is what's called the degrowth movement. Now they say it differs from the anti-growth Malthusianism of the 1970s and 80s. I'm skeptical of this myself. But it's a bunch of serious people, and they publish books and so forth. And to the extent you're interested in environmental thought and general themes, you need to know about these guys too. Almost lastly, so this is a faith-based institution here at Pepperdine, and lo and behold, I got persuaded about 15 years ago to write a short, it's about 70 pages long, theological treatment of environmental issues. I've got, 7 copies here, which you're happy to have. I've got enough for everybody who's here. I've got more ordered. It's out of print, but I have PDFs too. You're welcome to take a copy of that if you want. Because it's a general and theological approach, some of the data that's in it is a little outdated, but a complete explanation of the Cousinets curve appears in it, for example. So you're welcome to that. I used to publish, and then I started, when I went to Berkeley, I started doing traditional law and political science. But I used to do an almanac of environmental trends. The last one was 2011, so it's way out of date. I've got some old copies here you're welcome to have. And it has a lot more of the kind of thing I presented to you today. So please feel free to take that. I will mention that. Let's see if I can do this again. I'll mention that there used to be a website associated with it called Environmental Trends. It's still up on the web. I didn't have any staff help for it, and I was doing other things. It still exists. Everything on there is way out of date, and if we wanted to in our lab, we could make this a class project or a study group project, update it and revitalize it and get rolling with it. I'm pretty sure it's Sally Pipezone's. I'm sure she'll give it to me if I want it, because she's not doing anything with it. I thought it'd be dead. I was surprised to find that it still exists. Yes?
Yeah, so I was fueling my car with 85 fuel yesterday.
Oh,
so
yeah.
I kind of was like, don't break my heart. But I'm interested to know but I'm sure we'll talk later more about it. But the reason why I mentioned Tesla, because it's so more younger generation. Sorry if anyone has a Tesla in here, but like our generation kind of sees Tesla and is like, oh, this is the car to help the environment. But you'll actually look into it and see that climate change is it's turning into worse and worse because of Teslas that are essentially and I see the positive externalities, negative externalities
Right.
with all of it.
Your
But,
trade-off, right?
The trade-offs, yeah. So I don't know what the solution is.
Well,
but
I talked about this a bit last week. So if you take in last week's video, you'll see brief comment. I mean, just the merest surface one, which is there's a big trade-off there. Making the batteries, not just for Teslas or any other electric car, but also for the grid scale that we're trying to do in a big way in California. The environmental footprint of that whole cycle. Oh, by the way, I should have mentioned environmental life cycle analysis. This has been around a long time, but it needs to be revived. Well, you apply that to batteries, and all of a sudden it's not a slam dunk at all. It's less conventional pollution, but we're already at such low levels, there's not much to be gained if we all drive Teslas in LA. Okay. So trade-offs, that's back to my point. Let me get here to the end, and we can revive this thing if we want, or I only have like one or two more. Let's see. A really good book, and he's one of my favorite persons who passed away 3 or 4 years ago, Roger Scruton, very prominent British philosopher. He wrote what I think was the best conservative book on the environment in 30 years. And it got translated in a lot of languages. He's a really famous guy, an interesting guy. And this book is very good because the vocabulary is completely different. He doesn't use wonky language. He's a quirky guy. He was all for plastic bag bans, and I'd say, but Roger, if you actually go through the sort of the analytics of it, they're not really environmental slam dunks. Because I don't care. And he gave a values-based approach to it. It's the last thing I'm going to come to, almost the last thing I'm going to come to. So I went through sort of analytical tasks, including trade-offs. So I think this is the general policy guidepost, and I'm happy to talk to anybody either now, if you don't have to go, or by email about specific Capstone ideas or other interests. But my general policy guidepost that I've been trying to lay out here today, points 1 through 3, is economic growth, technology, property rights and markets are your friend and not your enemy. What I haven't talked about, because it's a whole big thing, is what's our regulatory strategy and legal architecture. So we go back to where we began. This requires a lot of time to understand. I'll put it this way. The kind of solutions we picked in the 1970s with the Clean Water Act, the Clean Air Act, the Endangered Species Act, the Toxic Substances Control Act, RCRA, Resource Conservation Recovery Act, go on down the list. Those kind of sort of centralized regulatory rulemaking approaches were perfectly appropriate to the problems of that time, which are problems of big scale, steel factories and auto factories and refineries. Environmental problems today are more diffuse. Surface water quality and surface water pollution is a good example, and it's gotten very complicated. And that old style of let's pass a big statute, let's hand it over to the EPA or the Army Corps of Engineers doesn't work as well for diffuse kinds of problems. So it requires different and more creative approaches that we're still not very imaginative about, in my opinion. So that's why I say the legal architecture, important to understand that, and we'll go through it in class, but that probably needs to change. Probably needed to change 15 years ago or more, but certainly needs to change now, and that's a large subject. So I'll stop here. That's my last slide. Went through things fast, barely scratched the surface, but you want to have a few things to start with. So any questions or comments or?
Well, first off, I just got this.
Okay, well, thank you. Yes.
So I opened up my eyes, I shared to you that after, to the environment and everything, but a comment that I had, it's like heartbreaking almost that this class isn't like full of us, because environment, it's the most important factor. It's, one of the most important.
Yeah.
I'm sorry
Well, we all live on
but
planet
I mean, we'd like to continue on living. So I just found it very eye-opening, the data sets that you have, but also having kind of movement for modernization with the understanding of these data sets, and it's actually very fun to hear about that there's some sort of political corruption with a link to environment policy.
Yeah.
And I was just thinking about so what, oceans now are being property rights almost for the fish, and
Property life. Sorry, sorry, keep going though.
yeah, but I enjoyed. I loved learning a lot of things, which I've heard, but yeah, but
So
it
first
was
of all,
great.
you told me your name earlier, but I've forgotten it already.
It's okay. Sama.
Salman?
Sama.
Sama.
Yeah, S-A-M-A. Yeah.
I can't hear or pronounce.
No, you're fine.
So first of all, actually, you should be encouraged. Here's why. This is what led all this with Dean Pete. Is I was here 10 years ago and actually did a class in energy policy that was filled up, but there wasn't a lot of broader student interest in the environment. That's changed. I've had Avery and a bunch of other people here say, hey, we really are. Oh, and what's his name? Who graduated? Our Australian friend, right? He's all into hydrogen. Declan, right? Declan, right? Yeah. I had lots of chats with him outside of class about hydrogen and this and that and the problems with hydrogen. And a lot of those students came to the nuclear power conference in whatever that was, March. There's a lot more student interest now than there was. And I know we're missing some people who were here last week. So actually, I think there's more interesting new things. So you should be encouraged by that. Instead of saying, where is everybody? Well, this is just an optional workshop to try and stimulate some imagination for people.
Of course.
Primarily, or initially, I'd say for capstone ideas, but really anybody. So, anybody else? No? You look like you're twitching back there.
Well, I'm curious how much you still see the influence of the Club of Rome and the population bomb, other type stuff.
Right.
Especially, people are starting to become more favorable of nuclear power.
Oh!
But it still seems to me that, you mentioned how environmentalists will get mad at progress, and it seems to me a lot of these more population-inclined people, it seems they get mad at nuclear energy because they're like, oh, shucks, it's going to actually give us all this energy and perhaps create the basis for more people to have energy and to live, and that's not a good idea because humans are bad.
I do think it's important sort of stand back. It took me a while to perceive this, and it wasn't until I started really spending a lot more time, really 20 years ago or more, spending more time with academics involved in ecology and fields of environmental studies. Now, you can find crazies in any subject in any university, but I found a lot of them who were decidedly not crazy and very serious and knowledgeable, but also they weren't prone to the sort of cliches of the activists. So by the way, I had a meme the other day. I didn't want to skip my memes. I've got a whole bunch of really mean Greta Thunberg memes, and I won't. I totally don't use those in class. But there's one the other day that caught me. It was person saying, we got this terrible problem. We got to do something about it. The person says, how about nuclear power? The person says, no, I want to throw soup at paintings. That's right. These are nuts. And you talk to serious people, serious climate scientists. They know these people are nuts. They're not helpful to them. Right, so they get all the attention because they're blocking roads and throwing soup on paintings in museums, but meanwhile, the serious work that's going on doesn't get as much attention. It's a very interesting and long story. So I make a distinction in my mind between activists. But by the nuclear power question, sorry, real quick, Pete. I've said for a while now, and I might have said it the first night we did this on Zoom, is that I never thought I'd be old enough to see so many environmentalists embrace nuclear power. And I've got the survey data that shows that the biggest change has been among Democrats. There's always been the partisan split, like there are on so many of these things between Republicans and Democrats, but the majority of Democrats, used to only be like 35% of Democrats support nuclear power. Now it's about 60%, it's nearly double. So I wake up here 6 or 8 weeks ago, maybe more than that, and there's Jennifer Granholm, the Energy Secretary, on hand to turn the switch on our first large new nuclear power plant in 30 years in Georgia. And she says, we need to triple the number of nuclear power plants in this country in the next 20 years, and we need to think about reopening plants we've closed down. And we're now going to reopen at least 2 of them. 3 Mile Island, that was, this is going to put Jane Fonda in her grave. You have to be old enough to remember her protesting nuclear power in the 70s, right? And then Michigan's going to reopen a nuclear power plant that they only closed 3 or 4 years ago. So wait a minute. New York, they closed Indian Point, which was, and their carbon dioxide emissions have gone up afterwards. And somebody said, "Oh, wait a minute. Well, we thought, it was going to be pixie dust and unicorn flop sweat would provide electricity." Well,
a lot of my friends in upstate New York, their power bills ever since they closed down Indian Point, just skyrocketed.
Yeah.
Especially, I forget the name of the valley, but the valley just above Manhattan,
right.
In that area, they just are saying that. It's just been killing them ever since they closed it down.
Yeah.
And I've heard that they've been having to rely more on coal or something.
Yes, and natural gas and imported power from Canada and elsewhere. my prediction is at some point, even the morons who run New York are going to say, you know, maybe we ought to reopen Indian Point. I think they'll figure that out. But, you know, Dean Peterson.
Well, I was just going off of Liam's point. We did have Jennifer Hernandez be here
Oh,
after
yes.
she wrote the article in Breakthrough.
Right.
The Green Jim Crow.
Yes. Oh, yeah, she's fabulous. I know.
And she is a woman of the left, but
I know. Yeah.
sees these environmental issues really as through the lens of civil rights.
Yeah, absolutely.
And
Yeah.
believes firmly that not only is there a desire on the part of some in the environmental movement to reduce population, but also just to make it very difficult for people of certain racial and ethnic backgrounds to live in places, because several of the environmental regulations, especially around housing and living, are meant to reduce the number of people living in certain places.
Yeah, so I go back to this one. There's a guiding principles of action to our values. I did not mention it all today. I did mention my little book on a theological approach to environment. But environmental justice is a big theme. There's some serious work's been done on that issue. If you actually read what the EPA has put out and say they're going to do, I think you will find it disappointing and bureaucratic, and I'll just sort of stop there. I've written a few things about it, kind of dated now, but if somebody wanted to do a capstone paper or some research project on that, that's a great idea. I've mostly done data and stuff you can quantify, because that's sort of my first pass. But point number 3 is perfectly suitable for a project, I think, and we'll discuss it in class some too. Yeah.
One thing I think is interesting, in particular on that you brought up, I did a little report a little while back on the East African crude oil pipeline that they're trying to build in Uganda and Kenya.
Oh yeah.
And I see that so much with the way a lot of international organizations will really attack Uganda or Kenya or anything for trying to develop any type of energy. The people who are using less energy than a refrigerator in their year, and
That's right.
and I remember Obama, he gave a speech where he was like, well, a lot of people all around the world want to have our quality of life, but if they had our quality of life, the whole world would burn over, so we can't have that. Or something like that to that line.
Yeah.
So,
Well, no, this is an old story. I mean, there's been pressure now, effective pressure for more than 20 years, that the World Bank not give any loans or loan guarantees for building dams or coal-fired power plants in Africa or anywhere.
Right.
So we'll do it. China says they're happy to do it. Well,
yeah.
so guess who gets the influence of these countries? Well, okay, nice going. So,
Thanks.
okay, sure thing.